Last application for dot product that we will look at is called projections. So what is a projection? It's basically if you have two vectors, suppose I have this vector and I have another vector, and the idea is I want to project this vector A on vector B. What projection means is if I were to pull this down, you can think of it as there being a light source and you're looking at the shadow. Then this would be the projection of this vector. Now, using some of the trigonometry stuff, right, we actually know how to find this unknown side. If you know this is theta and the length of this is the magnitude of A, then with respect to theta, that is your adjacent and hypotenuse. So it's really cosine theta is this. So this unknown quantity is A cosine theta. Now, because of the involvement of cosine theta, what this leads me to think of is there is another way I can phrase this as a dot product. So here, the scalar projection of A onto B is A dot B, and I will divide it by the magnitude of B. Why is that? Think of it. What is A dot B? That's magnitude of A, magnitude of B, cosine theta. And when I divide by magnitude of B, they get cancelled, right? So this is magnitude of A, magnitude of B, cosine theta, magnitude of B. Cancel. What is left? That's exactly what the projection is. Now, this can be used to find the vector projection as well. The vector projection of A onto B, well, how long is this vector going to be? The length of the vector is the scalar projection. So that's the length of the vector. What is the direction of this vector? Well, it's directed along B. So it's vector B divided by the magnitude of vector V. This gives us the direction. This is the unit vector in the direction of B. So using these two, we can find the scalar value of the projection as well as the vector projection. Let's look at an example. Find the scalar and vector projection of B onto A. Okay, so here B is being projected onto A. So it means we will have to divide by the magnitude of A. So I need the magnitude of A, and that's going to be square root of -2 squared plus 3 squared plus 1 squared. That's 4 plus 9 plus 1 is root 14. And A dot B is going to be 1 times -2 plus 1 times 3 plus 2 times 1. -2 plus 3 plus 2 is 3. So the scalar projection, also written as COMP, A projected onto B, B projected onto A, that's the component of, is A dot B divided by absolute value of A, which is 3 over root 14. Now, what about the vector projection? The vector projection will have a length of 3 over root 14. What will its direction be? Its direction will be the direction of b divided by the magnitude of b. So 3 over root 14, 112 divided by square root of 6. Sorry, this is in the direction of A. So this vector should be A here. We're projecting B onto A. So this should be negative 2, 3, 1 divided by another root 14. So this will be 3 over 14, negative 2, 3, 1. So that's the vector. That's projection of B onto this given vector A, and it's in the direction of A. So that brings us an end to discussion on dot product. In the next topic and the next series of videos, we will go over a different kind of multiplication between two vectors.